windows and yeah.
Just kind of make sure I'm you're in focus. Time's good there. We're now officially on we have the power.
Okay. You ready? Cool. We got one guy coming in. All right, we'll get started here again. My name is Andrew Norris. I'm the branch manager of BDI, Bearing Distributors, Inc. Been dealing with Camfil, Jed, Josh, Adam, James down in Colorado Springs for a while now. And it's been kind of a long-standing partnership with BDI, Air Filter Solutions, Camfil, longer than I've been around. But today I'm going to talk to you about lubrication, bearings, mounted bearings, and motor bearings, and common maintenance practices with these two products. There we go. So first, starting with motors. These Gold Baldor motors you guys probably see all over the place. There's other motor manufacturers, WEG, Toshiba, Tico, but WEG or Baldor is a very common one that we all see on air handling units, blowers, cooling towers. And then there's two types that are driven. From doing these seminars, I've learned that there's starting to see some directly driven fans. And that is when the motor is coupled directly to the fan itself with a coupling, which there's 10, 15 different styles of couplings. And then you have your belt driven, which is going to be what Tim from Timken just went over. All right, so heat is going to be your biggest enemy, which also plays with lubrication because lubrication is going to help you keep your bearings cooler. But heat is going to deteriorate the windings in your motor. And then you also want to make sure your motor sized properly. If your motor is undersized, it's going to be working a lot harder and cause failures because it can't keep up with what you're trying to do. And then also on the back of motors, you're going to see a little cover that goes over the back end. Do not cover that. Try and keep it clean. That is there for a reason. There's a fan that's in there that is running air over the motor itself to keep that heat down, which is going to, in end, protect your equipment. Motor's probably the most expensive replaceable item, so you want to keep that thing away or keep the temperature down on that. And then also you want to protect your bearings. So minimize vibration. Vibration is an enemy for bearing failure. Just trying to eliminate that. And then also checking alignment. That's going to help with your bearing failures. So what Tim had mentioned, alignment, if you need to use shims, you can to keep that thing properly aligned. If you're out of alignment, you're going to cause wear. So if you have, if you're out of alignment and your belts, they're applying tension in a different direction, or you have your picture like holding like a beer mug. If you have your weight far away from it, that is called overhung load, which is going to cause quicker wear for the bearing. But you want to have that stuff mounted as close as possible while keeping it aligned to reduce the odd loads that those bearings are going to see. And then, so that's, just mounting your shivs as close as you can, but while maintaining that alignment. And then also ground your motor to the conduit box and then you can also use shaft grounding rings. And then the number one cause of bearing failure is contamination and maintaining proper lubrication. Yeah, go with questions.
So we've got an air handler that's been running for 40 years.
Mm-hmm.
Supply motor with supplier ordered a motor, got the motor, replaced the motor,
Mm-hmm.
lasted 6 months. Took it out, put benefit, there was one.
Mm-hmm.
Put another one in, last 3. Now, we came across Albert on the motor.
Mm-hmm.
Well, the other 2 weren't rated for 6,000 feet. I have
Mm-hmm.
never heard that altitude has an electric motor.
It.
They're saying because the age of the first one was probably filled with heavier windings.
Mm-hmm.
There was motors in the unit itself.
Mm-hmm.
And it passed the coil, so that picking up extra heat. But on that motor, it actually does say footage. The other one's lower than 4,000 feet. It's going to be 6,000. You
Yeah.
ever heard that before?
I haven't, but like, I mean, with a lot of stuff, manufactured, 40, 50, 60 years ago, they're brutes, they last forever. But that's something that I would recommend. You could get us out there. We can look at it. You got a Wyoming hat on. Are you up in Wyoming? Okay, so that's something that I like to do with all of Camfil's outside sales force. It's going out seeing the application. It's like a field trip for me, just getting to see background stuff. But we can definitely, look at that with a motor manufacturer and say, here's what we're running into, get some answers to that. Because some stuff is, manufactured at sea level, but then there are certain products that I do sell that I have to tell them, hey, this is being used up in the mountains at 8,000, 10,000 feet above sea level.
Anybody else ever heard of an electric motor rated for altitude? No, I mean, that's just the horsepower.
I haven't seen that.
We got, I don't know, probably 200 pumps on Camfil.
Mm-hmm.
Another couple hundred motors. But they were installers years ago, and we put a whole bunch in there. When they're engineered, I've never noticed putting any of these in that they were spec for now.
Yeah. What was the original motor manufacturer? U.S. motor. I don't run into U.S. motors a lot. I do, but most of the motors here in Colorado I run into are Baldor and Wag. But I'd be. Do you still have that old motor? Okay. And then what did you replace it with? A U.S. motor as well? Yeah, if you got a nameplate, send it over to Josh. Josh can get it over to me. I can work with a couple different motor manufacturers, see what they recommend, and then let me know what you replaced it with. Because like motors back then, that thing's obviously obsolete, but we can look at seeing what the current replacement is for it, and see what compare that to what you used, and hopefully the one that you did get to replace that is. Mm-hmm.
I would have thought if I ordered this motor, they would have known it was for 6,000 feet. So apparently they've never heard of this out.
Yeah, that's new to me. Mm-hmm. So cool. Yeah, if you get. Yeah, send over original nameplate and or part number and the one that you replaced it with, and then we can kind of look and see, get with some motor manufacturers and get that over to their engineering team to see why you're having that fail. Because that seems very odd for, I mean, something to run 20, 30, 40 years, whatever, to go down from 6 months to 3 months. That motor what's the horsepower? 15. Yeah, so it should last, but should last much longer than that.
Yeah, I'll see if I can find this one that works.
Cool.
Nobody else has heard about that.
Yeah. So motor lubrication, how often are you guys lubricating your motors? Once a year. So motor lubrications, when you're lubricating the bearings that are in there, these lubrication intervals are going to be much larger depending on the horsepower size. The higher up you go on your horsepower, you're going to be lubricating it less periodically, but also speed is a factor of that. And so on this chart here, it's also going to vary on your frame size. Frame size is going to tell us what bearings are in there. And then on my next slide after this, talk about the procedures to doing that. But for example, like most of your guys' fans are running 24/7. If you guys are in hospitals, I would imagine 24/7. Schools, maybe not so much. But they're, I'm kind of the guy that when I get a box of Legos, I'm trying to build it without my instructions. All these motors, they do come with manufacturer instructions for lubrication, but there are, it's not going to be lubricated as much as you would a mounted pillow block bearing or a mounted bearing. So always pay attention to what the manufacturer recommends, and I'll always pay attention to what grease you are putting in there. Greases don't mix. I'll go into that a little bit. But for example, so like on a 210 frame, 10 horsepower motor, which you guys probably see a lot of, typically 1800 RPMs. Some of you might be working with 3600 RPMs. But that's going to be 3 pumps and lubricating it every 71 weeks. And then as you go higher on your horsepower rating, you're going to be lubricating it more frequently because it's bigger and the bearings inside are bigger as well. I'll go to the next slide here. There we go. So your bearing or your motors, 15 horsepower and up, are going to have grease zerks. Some, and I've seen it, kind of depends on the manufacturer, but typically for Baldor motors, you're going to have a grease zerk on there. You're also going to have a grease relief. You always want to make sure that grease relief is unplugged, because what that is doing, that's causing the grease to flow to parts that you do not want to grease, like your windings, and that's going to cause motor failures. But on top, when you see the grease zerk, I think you can see it. I'm going to step away here, but on the shaft end of the motor, and then on that towards the back where the fan is, there's going to be your grease zerks, and then right below those, you're going to have the grease reliefs. But make sure that you remove those grease reliefs, and then you want to grease. Some common mistakes: greasing until the grease purges out of the seals. Most of your bearings on a motor, it's going to be not visible, so that grease is purging out and going into your motor windings. And then also forgetting your grease relief. And then over greasing can cause damaged windings. And you can grease while it's running or stopped. If it's running, just make sure it's safe. Like Tim said, there's a lot of hazards from fast moving equipment. And then, remove grease relief starting at 15 horsepower and slowly add your grease. If you get it on there and you start pumping it super fast, that can also blow the seals out. Or actually not seals, they're shields. You can blow those out of the little, on the outer and inner ring, the part that shield clips to. And then you should see grease starting to come out of your grease relief. If you don't see it, it could be going elsewhere. So if you keep pumping until you start seeing stuff and you're not seeing it, it could have been over greased before, or the grease relief was not removed and you now have grease in your motor. And then afterwards, let it run for a minute and reinstall the grease. That's going to start churning that grease and start relieving more grease. You want to get that bad grease out of there. Further down in my slides, you will see kind of like your engine oil on your car. Your oil starts, getting real dirty. Then there's like a perfect scenario where it still has little broken down grease in there from heat and metal wear, which is going to cause your grease to, if you're putting in blue grease, it's going to start looking bluer with some black brown color to it. And then this is something that's relatively new, but a lot of manufacturers are doing it. This is, we all want to be preventative with our maintenance. If you're not preventative, maintenance is, or reactive maintenance is what you want to try and avoid. But we understand, budget constraints. So you're just fixing stuff when you can. But these Internet of Things, we've been doing a lot at hospitals, large campuses, but there's technology out there that you can monitor your equipment via Bluetooth, via your computer, using a gateway. But what these devices do is they will monitor temperature and vibration. There's charts that you'll see, if you're looking at air handling unit 1, there's a chart that you'll look at. It'll show 2 waves of heat and vibration. If your heat just starts spiking, that something could be wrong with that. If you see your vibration spiking, something, a bearing could be failing. If you see it just completely fall off, your unit might be turned off, or something might have came disconnected. But it's something that you can see without going up on top of a roof, going up to a space it's hard to get to, requires shutting something down. It's going to help you plan your maintenance versus react to your maintenance. Go on to the next one. Now we'll get into bearing failures. So I said, heat's an enemy, but lubrication is the number one cause of bearing failure. They say 1% is coming from manufacturer defects. I know we all like to blame it more on the manufacturer than the lubrication and other causes of failures, but lubrication is the number one cause of failures, and that's going to be from the wrong lubrication. Do you guys all have separate greases for your motors and your bearings? Mounted bearings? I want to see everybody shake their head yes. Do not mix the two. Age lubrication, on all lubrication tubes, there's going to be an expiration date on it. If you're buying it, just make sure that you're buying lubrication that has not been expired. There's a shelf life to it. Solid contamination, that's getting, depending on your environment, how dirty, how dusty it is, those contaminants are going to get into those seals, and you want to make sure that you're relubricating to purge out that grease and put fresh grease in there. Insufficient, so not having enough lubrication. This will go back to a chart further down. Depending on the bearing size, it's going to take more grease than a smaller bearing. And liquid contamination. Liquid is going to get in there depending on, if you're outside in the snow and you guys get dumped on up in Wyoming, or if you're up in the mountains of Colorado, water can get in there, and that's going to cause, corrosion. You want to stay away from that. But then other causes of bearing failures is going to come from the manufacturing defects, installation, so alignment, not having the properly sized bearing. But lubrication, number one cause of bearing failures. Yes.
Let's say you just installed a bearing. What indicators would you look for to determine whether they properly installed it or didn't?
So most of your air handling units, they're designed by some super smart engineer. They're speccing in hopefully the right bearing. There are cases where I work with OEMs, and we start with this bearing, they test it, it fails, but most of the time before it's up on your hospital, your school, or whatever, that stuff is spec'd in there. It's put in the right exact spot, especially for bearings. There's already mounting holes and everything. So most of the time it's going to be the right bearing that you are replacing. So making sure that you're replacing it with the same exact bearing or an equivalent. There's 20, 30 different bearing manufacturers out there. They're all going to make something that, the bolt hole spacing is going to be slightly different, but most of them are going to fall within that same, those diameters or the dimensions. Does that answer your question?
Well, I guess my biggest question is more or less like, these are the breakdowns of why bearings fail, right?
Mm-hmm.
Installation being one of them.
Yep.
What is the indicator that demonstrates that you've installed it correctly? Noise?
I'd say noise, but it kind of just, as long as you're replacing it exactly how it was before, where it was, on the shaft, you should be good to go. Yeah. And then you're like, what's this piece from? So bearing or lubrication is there to reduce friction. If you look at an inner ring or an outer ring of a bearing race, you're going to see little peaks and valleys, but what that lubrication does, it creates a coat around there, so those rolling elements or ball bearings, which are typically used in air handling units, are going to be protected by that film over that. If you didn't have any lubrication, that's going to cause heat with metal wear. That's going to reduce your bearing life. And it also protects against contamination, forms a dam. So on that little cutaway, you'll see that this particular part of my presentation is from Dodge. Dodge bearings are going to be different from Timken, are going to be different from other manufacturers, but most of the seals that are out there are very similar. Dodge is one of the only ones that uses this type of seal that they consider to where you can't blow the seals out. So I'll go into that here in a little bit. But the grease is continuously circulating, and it removes excess heat when you do relubricate your bearings. If you were looking at it through one of those sensors, when you grease it, it is going to cause a spike in your temperature, not a huge spike, but then it'll drop down to its normal operating temperature. If you were using those sensors and you continued to see a spike, there's something not right with that. So best to start looking at what could be causing that. I'll go to the next one. And then so grease consistencies, these charts, the NLGI, which is National Lubrication Guide Institute, I believe, the 000 all the way down to 6, that's going to be your consistency. So at a 000, you're going to be almost like a liquid. You're going to see that with gears. So similar to like oil in a car. And then as you go down the list, you're going to get much harder. But most of the bearing greases that you guys are going to be using is going to be an NLGI 1 or 2. 2 is very common. That's going to be like your peanut butter consistency, and that is considered a soft grease. And then how I mentioned before, bearing grease, mounted bearing grease versus motor bearing grease. Do not mix the two. I know this chart says it's borderline compatible, but mixing a lithium complex grease with a polyurea, that is going to cause that grease to almost turn into a clay. And that's the harder that bearing has to work in either your motor or your mounted bearing. It's going to cause it to increase your heat, which is going to cause bearing failure in your motor or in your mounted bearings. And then in this chart, so your low speed, this is based off of for mounted bearings. So that NLGI 2 is right in the middle. Going to be a medium speed, 1800, 3600 RPM. And then your oil viscosity, your low oil is going to be the super thin, high is going to be super thick. Right in the middle, you're going to have that very similar consistency of peanut butter, or what else was it? Peanut butter, tomato paste, vegetable shortening, so stuff that you have in your kitchen. And then as for mounted bearing greasing, lubrications, anybody use auto greasers or lube lines? So if you have like a greaser mounted outside of air handling unit. So yeah, there's those applications. Since you have that long travel distance, it's best to consult. You can get with Josh. We can get with a Dodge engineer or some engineer to tell us, how, if you're at 5 feet, how many pumps are you needing to get in there, whether it's a fresh line that you just installed or an existing one. But it's going to be measured off of your runtime, your RPM, and also your shaft length and shaft diameter. This chart, so 24 hours, and you're at 1800 RPM. So we're going to fall under that 1500 to 2000. You're going to be lubricating that every week. And that's not just sitting there pumping grease in. It's going to be putting in a correct amount of grease. Best times to lubricate mounted bearings is when equipment is off, before or after shutdown, or before shutdown and after washdown. And as always, if it's safe, you can lubricate while it's running, only if it's safe. And then this is that little chart So if your grease looks like it's coming out of your tube, that's you're purging out. You probably have too much grease in there. Right on the your guys' left, where it's looks kind of burned up, that means you need to increase your grease. And then right in the middle, where it might have a little bit of that burnt up, broken down grease, and the color of your grease that's coming out of your grease tube, you have a sufficient amount of grease. And so you guys are going to be kind of in between, or the low to medium speed, but pumping in grease until fresh grease can be seen, purging from the seals, and ensure full supply of fresh grease for bearings and seals. At high speeds, Dodge recommends slowly adding 3 pumps of grease per inch of shaft diameter at each interval. So on that previous chart, that would have been once every week. Does anybody use the automatic lubricators where it just pumps in grease? There's some that are spring operated, battery operated, or gas operated. So what these do is people think you're trying to replace, some tech's job on having him go around to a bunch of air handling units to grease it, but it alleviates that need, ensures you're getting the right amount of grease. There's dials that you set on them based on the application, bearing size, that'll automatically put that in to make sure you're not over greasing, under greasing. It's making sure that you're getting the right in there. Then they also can work with those sensors that monitor your heat and your vibration. And then back to the lube lines or auto lubers, consult manufacturer, engineer. They can calculate quantity and the interval for you for greasing. And then for the Dodge mounted bearings, here's a question that they get. I have grease purging for my seals before or after startup. I must have faulty lubrication, bad seals. That's wrong. So seals breathe. And with that, fresh grease will bleed oil by design. Fresh grease around the seal can suggest frequent lubrication. So you might be having the right amount of grease, or you could be over lubricating if you are seeing a lot of grease. I was up on top of a office building, and this bearing was just covered in grease. So it could have, before they took over, it could have been over greased before, but they're trying to get on a better maintenance practice and greasing correctly. So that is actually wrong. So that is common. Won't I damage the seals when I relubricate? For Dodge mounted bearings, no. Their seals are properly designed that they can be, these seals cannot be damaged by over greasing. There's a video on YouTube where they have a hydraulic press, just putting tons of pressure of grease into a bearing. The bearing just starts getting covered in grease. But Dodge bearing seals cannot, trying to find the word, they can't, the seals can't be blown out, or on some bearings, depending on the manufacturer's seal type, they can be blown out. And then just always know what bearing you're using. Some bearings won't even have a grease zerk, sealed for life. But then some bearings do say they're sealed for life and they have a grease zerk. But always look at the manufacturer's recommendations for greasing, just to make sure that you are in fact putting in grease when it does call for grease. And then that is all I have. But basically, so like what I like to do is like what your question that you had, we like to get out with you guys, solve problems. So if you have problems with bearings, or want us to look at applications with the drive design, we can do that for you guys. We put labels on air handling units to make it easier for you guys. When you go back to look at an air handling unit, you have it broken down with what shivs on there, what bushings on there, motor horsepower, belts that were used, all that information that's on there. With the drive design, it'll also include your center distances, so that way when you go back to tension those units, you know what frequency or what pounds of pressure needs to be put on that to properly tension. So get with Josh, get with whoever that you work with at Camfil. We can get something set up to go out, look at stuff on site, help solve problems. Any questions? Other questions? Good.
All right, we'll go ahead and stop there. We'll take lunch, come back here at about 12:15.